Okay, so today's notes are on solving systems in 3 variables using substitution and elimination. And our language objective will be to use correct terminology when explaining that process. So it's a little bit time consuming and tedious, so I'm going to jump right in. Just as a quick preface or background before we start our example, if it's in 3 variables, it means because it's 3 planes intersecting, and while drawing that in the notes is a little complicated, I'll show you a visual in class. To explain what I mean when I say it's 3 planes intersecting. So we'll talk about what exactly it means or what exactly we're solving for in this situation. But let's jump right into the actual process of doing it. So I want us to figure out what is the solution of the system. And I want us to use elimination to start. So since we have 3 variables, we need 3 equations. So whenever you're solving a system, you need as many equations as you have variables. So we have 2x minus y plus z equals 4. That will be equation 1. Then we have x plus 3y minus z equals 11. That's equation 2. And 4x plus y minus z is equal to 14, and that will be equation 3. So I'm also going to highlight them just so you can refer back to which ones I'm talking about a little more easily visually. So I have these 3 colors to start: blue, pink, or blue, yellow, and pink. So our first step when we're doing this is going to be to pair equations to use elimination. So the first 2 I'm going to use are 1 and 2. So I'm going to say 1 is 2x minus y plus z equals 4. And equation 2 I see is x plus 3y minus z equals 11. And I'm choosing to use these 2 equations. So 1 is blue, 2 is yellow. And I'm using these 2 equations because I can see right away that the z's are going to cancel. So I'm choosing to use these 2 strategically because I see the z's would cancel. I could also choose the first and third and cancel y and do that first. So there's not necessarily a variable you have to cancel first. It's more strategically which ones will be easiest to cancel. I'm also choosing to cancel z because I see I can easily cancel z with another one in a minute. But ultimately, be strategic in how you're trying to use elimination, and don't necessarily just cancel z or just cancel x. Strategically figure out what will be easiest to cancel. So here we get 3x plus 2y, the z's cancel, so equals 15. And I'm going to make this equation number 4, and I'll make it orange. So equation 4 is now orange. So now I'm going to do the same thing again. Step 2, I'm going to pair another pair of equations. And use elimination again. So this time I'm going to use equations 2 and 3. So I already used 1 and 2, so I can't use 1 and 2 again. I'm going to use 2 and 3 this time. So I have, I'll write 3 first. So I have 3 is 4x plus y minus z equals 14. And my other equation, if I'm looking back, I'm using 2. The z's are the same side, so it's negative z and negative z. So I'm going to multiply this equation by -1 so that I get negative 4x minus y plus z equals negative 14. So I just multiplied that by -1 and rewrote it. And then I'm going to add that to equation 2. So pausing for a second. Equation 3. I'm going to add that to equation 2. So then I have x plus 3y minus z equals 11. So hopefully you're following along. I'm eliminating again because I'm trying to get 2 equations and 2 variables. So here my z's cancel again, and I'm left with negative 3x plus 2y equals negative 3. So that's my equation, or my fifth equation, which I will use green for. So now, I know it's a lot of colors, a lot of things to keep track of, but if you can at least pay attention to the numbers. The main thing is I'm using the first two equations each time to get, now I have these two equations that are in two variables. So now I have a normal system of equations that I can use to solve for x and y. So the goal of the first two steps, so if you want to put a little star here, goal of first two steps is to get a system in two variables, because we know how to do that. So once we get a system with two variables, so I can use 4 and 5, then we're just solving like normal. We can use substitution or elimination again. But the goal with our first two steps, again, we're to use our three equations to get a system in two equations. So now that we've done that, step 3 is going to be to use the new equations to solve for x and y. So now I have my two new equations that I canceled out the z's strategically. Those are the easiest ones to cancel out in both set pairs of equations. So I now have two equations in x and y. You could also get two equations in x and z, or two equations in y and z. It's really up to whatever cancels easiest, but the goal is to get two equations in two variables. And now we can use these two to solve for x and y. So I'm going to use 4, which is 3x plus 2y equals 15. And 5, which is negative 3x plus 2y equals negative 3. So again, these are our green and orange equations, if that's helpful to color code them. But if just looking at them, I could use substitution or elimination to solve, but looking at them, I see really quickly that the x's will cancel. So I'm just going to use elimination to do that. So I cancel the 3 x's, and I'm left with 4y equals 12. I solve for y, and I get y is equal to 3. So I'm going to put a little star here. I used elimination. You do not have to use elimination, but this is the strategy I'm using. So now I have y, and I can substitute it back in to solve for x. So I'm going to use either of those two equations. I'll use equation 4 just because. So I have 3x plus 2 times 3 is equal to 15. And I get 3x plus 6 equals 15. 3x equals 9, so x is equal to 3. So then I substituted my y value in, so got my y value substituted in, got my x value, and now I'm 2/3 of the way there. So I have 2 of my 3 variables. I'm really done the vast majority of the work. The only other thing I need to do, I'm going to flip the page just so I have enough room to write this clearly, but just so you know, all I'm going to do is substitute these into one of my original equations. So, okay, so last step, step 4, is to substitute values into one original equation to solve for the last variable. So in this case, I'm going to use equation 2, and I'll say, which is x plus 3y minus z equals 11. And that was our yellow equation, if you're keeping track. And I plug in, I know my x value, I know my x value is 3. So I get 3 plus 3 times my y value is also 3. Minus z is equal to 11. So then I solve, I get 3 plus 9 minus z equals 11, which says 12 minus z equals 11. So negative z equals negative 1. So z must equal 1. So now I have my final variable. I've solved out for all of them. The last thing you should probably do is write it as a coordinate. So write the solution as a coordinate. Specifically called an ordered triple. and it's written in the form x, y, z. So I would write it as 3, 3, 1. So it's a 1. So my ordered triple is 3, 3, 1, and that's my solution. I'm all done. For the sake of time, I'm going to jump into our substitution problem. We'll do some practice together in class, but I'm going to jump onto the second example with substitution just so I can get through them now. So our next example, we're solving another system. So what is the solution of the system? And I want us to use substitution. And our system is going to be 2x plus 3y minus 2z equals -1, and x plus 5y equals 9, and last but not least 4z minus 5x equals 4. So I'm going to actually copy this onto the next page so that I have more room to solve this out, but I'm going to use these 3 equations to solve out the next problem. So I'll rewrite them right here. Our system is going to be 2x plus 3y minus 2z equals -1, x plus 5y equals 9, and 4z minus 5x equals 4. So 1, 2, 3. And we'll do them 1, 2, 3. Okay, so first thing we're going to do, step 1, I want us to isolate one variable. So just like we do with normal substitution, we're isolating one variable in terms of the other, or in terms of another. Or you could have, in this case, we lucked out because we already have an equation in 2 variables, so this makes it easy for us, but you could solve for one variable in terms of both of the others, and you'll see why in just a second. So I'm going to use equation 2, x plus 5y equals 9. This is our orange equation, and I'm going to solve for x and get x is equal to 9 minus 5y. So that's my equation in terms of another variable. If there were a z in there, it would be fine, because we're going to substitute it into another equation, which is our step 2. So we're going to substitute into the 2 other equations and simplify. So again, the goal of our first couple steps is always to change a 3 variable system into a 2 variable system. So we're going to do that by solving for one variable in terms of the others and substituting it back in. So I'm going to plug in this equation first to equation 1. So I'm going to have 2 times 9 minus 5y plus 3y minus 2z equals -1. So if this were a z, it'd be fine because it still would simplify to an equation in 2 variables. So it's okay if there's 2 variables when you isolate your variable that you're solving for. The goal is just to get only 2 variables in your next equation. So just so you guys can see what I did, I plugged the orange equation into the yellow equation, or equation 2 into equation 1, and I end up with 18 minus 10y plus 3y minus 2z equals -1. And if I keep solving that, I get 18 minus 7y minus 2z equals -1, and -7y minus 2z equals -19. So that is going to be my equation 4 now. So I'm going to use my blue, my now equation 4. So then I'm going to do that. I'm substituting into both the other equations. So I'm going to substitute 9 minus 5y into equation 3 as well. So I have 4z minus 5 times 9 minus 5y equals 4. And distribute, I get 4z minus 45 plus 25y equals 4. I move my 45 to the other side, and I'm going to rearrange so that my y is written first. So I get 25y plus 4z equals 49. And that's my equation 5. So now that one will be green. So now I have my two equations and two variables again, which again is always the first goal when you're solving a three variable system. You try to get two equations and two variables and then solve your normal system. So now I'm going to solve my normal system. So to do that, I'm going to rewrite my equations. I have negative 7y minus 2z equals negative 19. This is equation 4. And I'm going to, and then I have 25y plus 4z equals 49. I can see here the 2z and the 4z, if I multiply this by 2, those will cancel out. So, sorry, getting ahead of myself. I'm going to multiply equation 4 by 2 so that I can use elimination. So I end up with negative 7y minus, negative 14y minus 4z equals negative 38, and 25y plus 4z equals 49. So these are again equations 4 and 5. I add them straight down and I get 11y. The z's cancel and this equals 11. So y is just equal to 1. So now I've solved for one of my variables. I just have to plug it back in and solve for the other one. I can use either of my two equations. I'm going to use equation 4. So I get negative 7 times 1 minus 2z equals negative 19. So negative 7 minus 2z equals negative 19. Negative 2z equals negative 12. So z is equal to 6. So now I have my second variable. And then my last step, as you may guess, I'm going to turn on to the next page, but it's to substitute into the original and solve for x. So I use equation 4, just clear. So I'm flipping the page. And I'm solving for equation, or for x. So I'm using equation number 2. So I have x plus 5y equals 9, which becomes x plus 5 times 1 equals 9. X plus 5 equals 9, so x is equal to 4. So my step here, step 4, solve for final variable. And then write as a ordered triple. So I end up with 4, 1, 6 as my solution, and I am done. Just as a final thing. All right, so that's it for solving three variables. We'll do some practice together for sure, but make sure you write down any questions, comments, concerns you have so we can go over them together in class.